Hello, this is Mrs. Clausing. We're going to go through the odds, or most of the odds on the homework here, kind of give you a guide for when you do the evens. Again, you have to do all the odds as well, but I will go through most of them with you on this video. This is a good review of Unit 5 so far, so just keep that in mind as you're going through it. And remember, your Unit 5 test is on Friday for odds and Monday for even classes. Okay, so remember here, the number 1 we'll start with, we're trying to add or subtract. Shows better on your printout, but add or subtract radicals. To be able to add or subtract radicals, they have to have the same index and they have to have the same radicand. So I'm going to look at each of these 3 pieces, or terms. And my most simplified term, or the one I cannot change at all, is the 5 in the middle. The square root of 5, it's already fully simplified. There's nothing I'm going to do to change that. So the only thing I could do is try to make my other 2 terms have a radicand of 5 so I can add or subtract them. So let's start with the 45 here. I'm going to think of my factors of 45. Remember, I want one of them to be a 5 because it has to be a 5 to combine with that middle term. So 45 divided by 5 gives me 9. Remember, 9 times 5 is 45. And so I can split it out, and then the square root of 9 is 3. So a 3 is going to come out and join the negative 3 that I already had out front. All right? And this 5 is trapped under the radical. Trapped as a radicand. This middle term, again, we already decided it's fully simplified. There's nothing I'm going to do to it to simplify it, so I'm just going to write it down. And then here, remember this 20, I need it to have a 5 underneath. So 20 divided by 5 leaves me with a 4. Square root of 4 is a 2. And it's going to join outside the radical my positive 3 that's already out there. Okay, and then this 5 is stuck under the radical. Okay? So now I'm just going to clean this up a little bit. Over here, we're going to skip number 3. Alright, over here we have negative 3 times 3, and that gives me a negative 9 root 5. Remember, this middle piece is really nothing I can do to it, so I'm just going to write it down so I don't accidentally drop it. And at the end here, we have 3 times 2 on the outside, so that gives me a positive 6 root 5. Alright, so now I can just combine. I'm adding and subtracting radicals, and my radicands are all the same. They're all 5s, and my indexes are all the same, so I just add or subtract what's on the outside. Remember, when I don't see something, see a number on the outside, I know it's a 1. So we have a negative 9 minus 1, which gives me a negative 10, plus 6, which gives me a negative 4, and then my radical 5 just kind of tags along. Okay? So my answer is negative 4 root 5. Alright, so let's go on to number 5. Okay, so there's a couple of ways we can do number 5. Probably the easiest way is to simplify it first and then solve divide the numerator from the denominator. Divide the denominator from the numerator. So that's what I'm going to do here. Alright, so, oops, let me erase this up here just a little bit so we have a little more space. I'll just rewrite it. So we had equals negative 4 root 5. Alright, so now I have more space down here. Alright, so number 5. So I'm going to simplify each radical first. So I'm taking the square root because my index isn't shown, so I know it's an index of 2. And I have 20, okay? So I need to think of a factor of 20 that's a perfect square. Well, that would be a 4. The largest factor of 20 that is a perfect square is 4, and 4 times 5 is what gives me 20. So my 4 is going to, taking the square root of it, will give me a 2 out front, which will join this 4 here. So that'll give me a 4 times a 2 out front, and then the square root of this 5 right here is trapped underneath. Alright, so my numerator radical is now simplified, so let's do the same thing for the denominator. Alright, so I'm just going to try and simplify this. The largest factor of 125 that is a perfect square is 25. 25 times 5 is what gives me my 125. So square root of 25 is going to give me a 5 out front of the radical. There's no other number out front here to join it with, so it's going to be a 5. And then the square root of this 5 is what's trapped underneath. Okay? So now I just need to clean this up a little bit. 4 times 2 is 8, square root of 5, over 5, square root of 5. Now think about it this way. When I have x over x, we all can agree that that equals 1. When I have 3 over 3, that equals 1. So let's look at this here. We really have square root of 5 over square root of 5. Can everyone agree that that really equals 1? And anything times 1 is itself. So really, this equals 8/5. Our root 5 over root 5 cancels out, leaves me with 8/5 is my answer. Okay? Alright, so let's go on to the next section. So I want you to make sure you do 2, 4, and 6 for homework. Alright, number 7. So down here, all you're doing is you're identifying domain and range. This is from Unit 5, Day 6, Part 1. If you're trying to look up your notes and trying to figure out where we're at, this is from Unit 5, Day 6, Part 1. Okay, this next section here, 7 through 9. Alright, so first thing we need to do, again, you can just plug these straight in your calculator, but let's do it the real way, so at least we recognize how to do it the real way, and we'll look at the calculator on the number. So 7 we'll do it the real way, or the long way, and then 9 we'll just plug it in the calculator and take a look at the graph. Okay? So I know that a square root graph, the parent function, and I know the parent function for this number 7 is y equals square root of x. I also know that the domain for y equals the square root of x is 0 to infinity. This is all the parent function we're talking about here. I know the range is also 0 to infinity for when my parent function is y equals the square root of x. Okay? Okay, so now I can look at my transformations in this function here. I have a number hanging out with my x, so this is an x-axis shift of what the opposite, which is, so it's x-axis shift of -2 because it's a +2 in the equation. And then I have a y-axis shift here of -4 because remember my y-axis does what it says it's going to do. Okay, so going from my parent function to the domain and range for my actual equation here is all I have to do is I have to increase my x-axis or my domain by the x-axis shift and my range by the y-axis shift. Okay, so the domain, remember domain are my x-axis, so my domain for this function is going to be -2 to infinity. Okay, notice it's 0 minus 2. 0 minus 2, so let's see, how do I want to do this? We have 0 minus 2 got me down to this -2 here. Okay? Alright, so that's where that's coming from. We'll just leave that blue line there. And then my range, same thing, but remember range are my y values, so I'm going to take the y-axis shift, so -4 now, to infinity. Okay, so my parent function transforms based on my transformations for square root graphs. Okay, so now I could just sketch this graph, and I know that I'm going to go -2 and down 4, and it'll look something like this. Okay, the parent function, remember for square root graphs, looks like this. Okay. So this one is y equals square root of x, and then this one is, the red line is y equals square root x plus 2, so enough space, x plus 2, and then -4. Okay? Alright, so let's just do it on our calculator again. We could have done 7 on the calculator as well. But it's good to understand where numbers are coming from, so when you look at a graph, you know whether it's reasonable or not. Okay, so number 9, let's go to our calculator, and we're just going to type in square root of x minus 1 minus 3. Maybe. Go to 1. Y equals, we have square root x minus 1 minus 3. Okay, graph it. All right, so number 9, we can see that we shift from the origin, we shift to the right 1 and down 3, which is what we would expect if we recognize our transformations. So looking at the graph, we shift to the right 1 and down 3, and it looks like this. Okay, which makes sense because remember this is y-axis of minus 3, so we went down 3 on the y, and then this is an x-axis here, x-axis shift of plus 1. Okay, so we see what we would expect to see knowing our transformations, but we can always just plug it in the calculator. All right, so quickly, if you look at this graph and do the domain and range, my domain, the lowest value for x is right here at this point here. My domain goes from 1 to infinity. And my range, my lowest value for y, again, is right here, which is -3 to infinity. Okay, which makes sense because remember we talked about how our transformations affect our domain and range for square root graphs. All right, so let's go on to the next one. So that's 9. Oh, this is a different. This one. All right. Uh-oh. Okay. So let's do 11 here. So remember, we have these top ones we're just multiplying radicals. So number 11, we're multiplying 2 binomials. Remember, when we multiply binomials, we use FOIL. Okay? So my first, color code this, first times first. Remember, when we're multiplying radicals, as long as their indexes are the same, we multiply the outsides by the outsides and the insides by the insides, or the radicands by the radicands. So -2 times 3, -2 times 3 gives me a -6. And then underneath the radical, my 2n times 3n is going to give me a 6n squared. We'll take care of that square when we're cleaning it up at the end. Okay, so that's the first outer. We have 2n times -2n root 2n times root 5. Remember, indexes are the same, so I can multiply the outsides. If I don't see an outside, I know that's really a 1 right there. So -2 times 1 gives me a -2. And then under the radical, I end up with a 2 times 5, which is 10n. 2n times 5 is 10n. Okay? Inner. We have, remember, if I don't see what's on the outside here, it's a 1, so I have 1 times 3, which is a +3, and then inside I have 5n times 3n, which gives me a 15n squared. Okay? And then lastly, we have these. So we have 1 times 1, which gives me a 1. And then underneath the radical, I'm going to end up with 5n times 5, which is 25n. Okay, so now let's just clean these up a bit. Let's start with this. Let's start with the red, the first term. So let's see, is there anything I can pull out from under this radical? And there is, because I'm doing the square root and I have a perfect square underneath. The 6 I can't pull out because 6 is not a perfect square. None of its factors are perfect squares. The 6 is stuck under the radical no matter what. Okay? But this n squared, the square root of n squared, is n. So 1n can come out from under the radical and join the -6 that I already had out front. I'm going to scratch this out so we don't get confused by 13. Okay. Alright, so I took care of the first term. Now let's go on to this green term here. 10. Is 10 a perfect square? It's not. Are any factors of 10 perfect squares? They're not. So the 10 is stuck under the radical. What about this n here? There's one n, but remember, since my index is a 2, they can only come out in pairs. And this n doesn't have a partner to pull it out, so it's stuck under the radical. Alright, so that doesn't change. So let's go on to the next term. I have 15n squared under the radical. 15 is not a perfect square. None of its factors are perfect squared. So the 15 is stuck. What about the n squared? Remember, we have an index of 2, so the n has to come out in pairs, and there are 2 n's, so the n can come out from under the radical. And then we have a positive 3 that was already out there. Okay. Remember, another way to look at this is when you're simplifying variables under radicals, you take their exponent, which is a 2, divide it by my index, which is a 2, gives me 1n, no remainder, so 1n came out from under the radical. Okay, one other way to think about it. Okay, so let's look at this last piece and see if there's anything I can do here. 25, is it a perfect square? Well, it is. So 25 can come out and join the 1 that's already out front here. Square root of 25 is 5. Okay, 5 times 1 is 5, so that's going to give me a 5 out front. And then the n does not have a partner, so it is stuck under my radical. All right, so now I'm going to just combine the like terms that I have. Remember, adding and subtracting radicals, that's all we're doing once we get down to this last step. We're just adding and subtracting radicals, but to be able to add or subtract them, they have to have the same radical. They have to have the same radicand, and they have to have the same index. So let's see, do any of these have the same radicand or the same index? I don't see any that do. So since they don't, this is fully simplified. There's nothing I can combine because I can't simplify any of these radicals any further. They're all fully simplified. And their radicands don't match. So that's my answer. Okay? All right, so I'm going to skip 13 and move on. I want you to do, let's see. I want you to do the evens here. 10 and 12. Actually, we'll go ahead and do 13. All right, I'm going to erase this so that we can see 13, but you can pause it and go back if you need to see this number 11 further. So let's do 13 together. All right, 13. Okay, so we have the same index, and we're multiplying radicals here. So if they have the same index, I can combine what's underneath the radical. So that's what I'm going to do first. So I'm just going to combine what's outside together and what's inside together. Remember, when I don't see my multiplier out here, I know it's a 1. So 5 times 1 gives me a 5. And then under my radical, I'm going to end up with 15 times a negative 18, which is a negative 270. Just type that in your calculator. And then I have x to the 4th times x to the 4th. Remember, I add exponents when I multiply variables with different exponents, so that gives me an 8. So I end up with x to the 8. All right, so let's just clean this up. Whenever I have an odd index and a negative underneath the radical, the negative just pops out front. Okay, just pops out. I is when you have an even index. Remember when we talked about imaginary numbers last unit? That's when I have an even index. But here I have an odd index. Odd index. So negative pops out. Okay, negative just pops out. All right, odd index. That's an O. Okay. But I need to keep simplifying. I already have a 5 out front. And then this 270. Cube root of 270. Well, it's a little trickier. You kind of have to think of your perfect cubes. And I know that the 270 is the same thing as 27 times 10. And I know 27 is a perfect cube. So the cube root of 27, I also know, is a 3. Okay. And so that's going to leave me with a 10 under my radical. I'm going to leave a little space because I'm going to still need to see if this x to the 8th can come out, but I know that 10's trapped under the radical, so I can go ahead and write that down. All right, x to the 8th. Remember, I'm taking my exponent, 8, dividing it by my index, which is a 3, and 3 goes into 8 twice with a remainder of 2. So 2 x's will come out. Gives me an x squared outside my radical, and 2 x's are stuck under the radical. They don't have another partner to pull them out, so they're stuck under there. All right, so let's just clean this up. I have negative 5 times negative 5 times 3, which gives me a negative 15 x squared outside, and cube root of 10x squared under the radical. Okay, and that's my answer. Okay, so that should get you through that section. All right, let's see. I'm going to skip around a little bit, try and keep this under 25 minutes. Let's do number 15. So again, I'll erase a little bit of this. Again, you can pause it, rewind it if you need to see some of that. Okay, so number 15. Actually, number 15 we're going to skip. Number 15 you don't really need to know. So let's skip 15. I'll do one of the evens. So skip 15. So 14, we're going from radical form, notice I have a radical here, to exponential form, which means I don't have a radical. All right, remember this from your quiz. What you're really doing here is you're taking your cube root and you're just going to turn it into an exponent first. So I'm going to end up with 7n to the 4th, and then raised to the 1/3 power, it will end up being, because this 4 is on the furthest outside here, so it'll end up being 7n to the 1/3 power. Doesn't really matter once you do the math, but anyways, and then raised to the 4th. So I've gotten rid of my radical now by turning it into the 1/3 power. Remember, power rule says that I multiply here. So 4 times 1/3 is 7n to the 4/3, still in parentheses. All right. So then I can just distribute to each exponent inside the parenthesis and see if we can simplify this any further. So I'm going to end up with 7 to the 4/3, because remember the exponent here is a 1. 1 times 4/3 is 4/3. And then n to the 4/3. And then we can see if this 7 simplifies any further, which I'm not sure. So we just go to our calculator, and we say 7 raised to the 4 divided by 3. Oh, divided by 3. And it doesn't simplify further, so we would just leave it as, you can either leave it as this, or you can leave it as 7n to the 4/3. That would be acceptable as well. But realize that those two things are saying the same. This and this one up here are saying, these two things are saying the same thing. Okay? All right, so do number 16 there. All right, so then we go on. Let's do one from this section. Let's do number 17. And I'll let you do 19 and 18. So 17 here. So we want to simplify this. All I'm doing is I'm trying to figure out of this 32, we're talking about square root, remember? So I need a factor of 32 that's a perfect square. Well, I know that 16 is a perfect square, and it is also a factor of 32, because 16 times 2 is 32. So the square root of 16, mark out this so we don't get confused. The square root of 16 can come out from under the radical, and square root of 16 is a 4. It joins the negative 3 that's already out front. And this 2 is stuck underneath. Now I'm going to leave some space because my b might be able to come out. So underneath I'm going to leave a 2. And then I'm going to look at this a and this b. So remember, the a, I take my exponent, and my exponent is a 2, and I divide it by my index, which is a 2. So that leaves me with 1. So 1a comes out from under the radical. Okay? No remainder, so no a's are stuck under the radical. Then the b, I take my b, which is exponent, which is a 4, divided by my index, which is a 2, and that gives me 2 with no remainder, so 2 b's come out from under my radical. And that's my answer. I'll write this a little more cleanly. I left space under the radical because I wasn't sure if I was going to have to stick anything else under the radical, but I don't. So let's clean this up now. Negative 3 times 4 is a negative 12. And then I have a b squared square root of 2. And that's my answer there. Okay? Okay, let's see. Let's go down here and do some of these. Okay, I'll try and keep it under 30 minutes. Let's Let's do number 21. Okay, this is solving. So when we're solving equations with exponents or with radicals, remember we have to try and get the variable free. So here we have an x. My goal is to get this x by itself. I'm solving for this x right here. We're going to do 21. So first thing I'm going to do is I'm going to try and get anything away from the x that I can. So I'm going to go minus 5 from both sides, get this 5 away from it. 30 minus 5 gives me a 25 equals x to the 2/3. And then remember, we talked about how to get rid of exponents because I want to get this x by itself, so I got to get rid of that exponent. To do that, I'm going to multiply by its reciprocal. So I'm going to multiply the reciprocal. The reciprocal is 3/2, okay? Because 2/3, the reciprocal is 3/2. So remember, that will leave me with 1. So I end up with x to the first. Over here, what I do to one side, I have to do to both, so I still have to raise this right side to the 3/2 as well. So I have x to the first equals 25 to the 3/2. Okay? Now I can just put this in my calculator and see what 25 to the 3/2 is. So 25 to the, you don't have to use parentheses on your calculators, but do on mine, is 125. So x equals 125. Okay? So remember, my reciprocal is what I was multiplying by on both sides. Okay. Let's just do one of these real quick. Let's do 25. Then I'll leave the rest for you to do, bring to class. So 25. Remember, when I'm solving, I'm really trying to get this m free. I want to find that variable. I want to know what it equals. So I'm going to do that, I'm going to get rid of this radical sign. The opposite of taking the radical right now is a square root. The opposite of taking the square root is squaring. So I'm going to square both sides. Okay? Or really it's the inverse. So 4 to the second power, so 4 squared is 16 equals, and my radical cancels with the square and leaves me with 1 minus 15m. Alright, now my m is mostly free. I just need to clean it up and get all the numbers away from it. So I'm going to move this 1 over by subtracting it. So that gives me a 15 equals, the 1 gets canceled on the right, negative 15m. Now I got to move this negative 15 away from the m, so I'm going to go divide by negative 15 on both sides. That leaves me with a negative 1 equals m. That's my answer there. Alright, so it was a little bit longer, but I think we all needed a little more practice on this, so I think this will be good. It's a good review for the test, so make sure you finish the rest of the problems for your homework, and you write down all the ones we did on the video as well, and I will see you next class.